I want to measure some specific stuff to continue my 3D printed smart LED wall panel project. I found a perfectly fine solution that I can just purchase for about 60 euros. And sometimes I just don't want to do that. Where's the fun in that? Where do I learn new stuff by getting frustrated because I f***ed up? Working on my projects makes me feel something. It reassures me that I'm alive. That slow frustration that builds up because you try something over and over again and it just doesn't work. Stupid mistakes because you just didn't read the instructions or spec sheets. Hours wasted because of your own incompetence, contemplating your sanity. And that sweet final relief when you finish some project that you spent way too much time on. No more sleepless nights. No more random expenses, the first rays of sunshine that hit your face again after being indoors for way too long. And somehow I like to document that stuff for you in 4K. So, welcome to another video. My name is Roman, and in this video I'm going to build an ESP32 thermometer, I think. I want to build a 3-sensor thermometer to test temperature differences for the 3D printed smart LED wall panel that I'm working on. If you're familiar with my recent project where I spent all of my free time for the last months, the 3D printed smart LED wall panel, which is behind me here as well, you might know that I'm looking to create different exchangeable panels with different shapes and textures. I want to further develop these panels, but there's an issue. The space between the LEDs and the panels is limited, and I want to test how far I can go and to get the best results possible. And when I created the first panels, I already did a little test. For the first design that I published, I went with panels that used the least amount of filament and let through the most amount of light. I have a different panel here that has a closed back. So the light is diffused twice and it loses significant brightness as well. But the color is way more confined to the grid area that should light up with each individual LED. So the designs are looking better and more pronounced. A downside to this is that there's less cooling space for the LEDs. And that's exactly where this thermometer that I'm going to build is coming in. I mentioned before that I wanted to get started experimenting with ESP32 boards as well. And this seems like the perfect use case for that. So I got a bunch of random stuff that was listed on a website about how to build a ESP32 thermometer. Thank you, randomnerdtutorials.com. I wanted to build a thermometer with 3 sensors. My idea is to mount one next to the panel, one on the left row with panel type A, and one for the other row with panel type B, for example. I'll let the LEDs run for a certain amount of time and see if there's a noticeable difference in temperatures. In my mind, this should also give me more accurate measurements than running 3 separate tests with different panels, because they're all running at the same time with the same room and temperature conditions. Now, let me step aside and show you the game plan that I've got over here. First, we have the ESP32 controller. You have to install and flash it and put some software on there. And then I want to build a proof of concept using this breadboard, so we can test out all the electronics, cables run, etc. If everything's working, we can then solder it and make it into something permanent later. And to tidy everything up, I want to create a custom 3D printed case with Blender and 3D printing, just to protect the electronic board and make it look nice. And if everything goes to plan, which hasn't been the case for the last projects, we should then have a 3-sensor thermometer to continue experimenting on the smart LED 3D printed smart 3D printed smart LED wall panel. I think that's the one. And as you can see, I also found a way to put the brightness at 100%, so it should look better now than the release video where I didn't notice it was running at 50%, which it does every time it boots, but that's a different thing. So let me know what you think and how it looks in this video. Let's get started by flashing the ESP32 controller just to get something on there and to make sure that it works. Let's head over to the computer and get started. If you are unfamiliar with ESP32, ESP32 are small computers with Wi-Fi that run on very little power. So you can make purpose-built devices, and therefore there are a ton of use cases for them. Like this project where I want to build just a thermometer. But I also want to do a future project where I'm going to build an ESP32 WLED desk lamp. So make sure you're subscribed to see that video when it goes live. This is my first experience building something with an ESP32 board. I do have experience with running computer components, flashing firmwares and installing strange stuff. I ran Clipper on my CR10, run Home Assistant on the Raspberry Pi, and I have Linux Mint running on my laptop here. I also run my own Wi-Fi network, and I built every computer I owned since I was 10 years old. So I might have a little bit of an advantage being new to ESP32. But hopefully I can make it easy to follow, exciting and interesting for you as well. To see if the ESP32 board is working, I start by downloading and running Arduino IDE 2 for Linux. I use the app image and I had to set the properties and then permissions to allow executing file as program, and after that you can just double click it to run and open. I connect the ESP32 board with an USB-C cable to the laptop. You can see the board powering on with the red LED. Under the Select Board drop-down, I can now see the unknown USB device listed. When I select it, a prompt pops up to select the type of board that I'm using. I didn't even know what ESP32 board I was using myself at this point. So I looked up the Amazon listing, and the only references that I got was something with WROOM or CP2102. But the board that I was using is not listed yet. I had to install a boards manager, so I installed ESP32 by Expressive. I think there's some sort of bug because it didn't find anything anymore and it did an empty search, or so it looked like. So I closed the application and opened it again. After that I was able to find a WROOM board. So I went with that one. The next step is to push a piece of code onto the ESP32 board to make one of the LEDs that it has flash in a color. So we know we can assign commands and software to the device. So I copy the piece of code and I try to send it to the device, and it didn't work. I got two errors: port is busy or doesn't exist, and access denied. I tried to add myself to the group that it mentioned as a hint. This didn't work either. I don't know if this was a Linux Mint thing, as the group itself didn't show up either when I was looking for it. I created the group manually, added myself. It still didn't show up or work either. And eventually I was able to add myself through the Users and Groups menu from Linux Mint. And there are two groups with the same name visible. One was already checked and the other one wasn't. I don't know, but after adding myself to those two groups manually through the GUI, it finally worked. I tried pushing the config again, no errors, and another LED started blinking. So after 2 hours, I don't have the feeling that I completely flashed a new software package to it. only that I uploaded a small piece of code. I'll have to further look into how that exactly works with ESP32, but for now my board is functional and controllable with a flashing LED. It's working. I call this a success. Let's continue with the breadboard setup. Alright, so the next step is to connect everything to a breadboard to make sure that we have a working setup before permanently soldering everything together. And this just makes the connections to the cables, and yeah, it makes it easier and gives you something to test. And I have a set of DuPont wires here. They come in a kit with 3 different types. This is female to female, male to male, and male to female. So we have all versions that we could possibly need. I have my ESP32 developer board. I don't know if I mentioned this before, but this is a developer board because this is the ESP32 sensor, and the developer board means that you get all the other functionalities like Wi-Fi and power supply and so on. It's all in one nice package. And then we have 3 DS18B20 sensors. In the schematic they look a bit different. That's because those are the short versions, sensor only. But I wanted them with a 2-meter cable on each one, so that I can really run them to different positions on my wall panel. So this gives me plenty of cable to work with, and they are in a nice sleeve and waterproof as well. So who might know, for which we can use these later for different purposes as well. And that's everything that I'll be using. Yeah, and some resistors. I just need one, but this is just a kit with 1200. Yeah. So let's get started. As the schematic is provided, this step is pretty straightforward. I have to place all the parts on the breadboard as shown in the reference image. Let's do a montage. So this should be everything for the breadboard step. I hope everything's connected properly. I had a little bit of difference between the references and my ESP development board, because the number of pins, I had less pins than in the image. So I just assume that GPIO 4 is like D4 or data port 4 on this board, as it was the same reference in the image, just not the same pin number. So I hope that works. And for the rest, these wires on the sensors are very loosely connected to the breadboard, and they are quite tough, and every movement makes them pop out, so I really have to watch out for that. But we're gonna give it a go, and I think that by USB powering the ESP board, everything else gets powered, but that's just an assumption. I don't think I have to use a separate power supply for the breadboard, but I'll find that out as well. So we're going to go to the Arduino IDE again, and I'm going to load some sketches or another software on it, something like OneWire and Dallas temperatures. Those are sort of software packages that you need to read these sensors and the stuff that we need for this project. You can find and install these libraries under Sketch, include libraries, manage libraries. You can just search and install the version of the library that you want. Alright, so the libraries are installed now. I have to restart the Arduino IDE to read the libraries with the sketches. I've connected the serial monitor as well. I don't know if this is visible. We can also see the LED on, LED off now. So I'm going to paste all the code that we need for the sensors. And this code starts with the one wire and the Dallas temperature includes. So that's why it needs those libraries as well. I don't see any smoke, so I think that's a good thing. But I don't see anything else happening either. I had to disable and re-enable the serial monitor before I got data. And we get some temperatures now in our serial monitor, which is very nice. But I only see... I have 3 sensors now. Let me show you a little bit better. We have device 0, 1 and 2. So those are 3 temperature sensors. So everything's already working as intended with this breadboard setup that I have over here. And we should also, if I use this sensor and I hold it, one sensor is raising in temperature now. This is device 2. So everything is working, which is really nice. So let's check this off the list as well. This went really smooth, and let's continue soldering. So yesterday evening, after putting the breadboard together that looked rather complicated, all based on this image, I get why it looks complicated, and wiring everything up as I have it over here on the desk, it has a lot of wires, a lot of excessive wires as well. So I tried to simplify that to something that I could solder more easily and was more understandable to me for what I have to do. And then I got to an even more simplified version where I'll just use the 3 cables that come from the senders. I bunch these together, the ground wire, the data wire, and the, I don't know what to call it, power wire, voltage wire, positive wire. And the only thing that I need to do in between is then put the resistor there from the power to the data. And then those 3 will go into one wire towards the ESP. And I think that should be it. And this is also the first time that I think I understand why you would make custom PCBs for certain applications. This is the first time that I can visually see the benefit of it or a use case for it. Just having the circuitry all nicely tucked away in a PCB with all the circuitry underneath, and you just solder the sensors and the pins where they should go. So, yeah, let's get to soldering.
Stay in the moment. I'm already far past orbit. Hands up like we're catching comets. Close up, feel the pressure on us. Past the limit, we don't back down. Right
So here's the first part of my creation. I decided to sacrifice some of my DuPont wires for the greater cause. This way the cables can be easily connected and removed from the ESP32 board later on. I probably should have done this in the first place instead of the shorter wires, but I didn't want to loosen those again, as it was a nightmare to solder the 4 wires all together at once. I finished soldering everything. I went from this fairly complex looking breadboard setup to this simplified soldering circuit thing. I don't have these shrink things to go around the cables, so I want to fix it in my 3D printed model that the cables remain separated. But for now I just have to be sure that they don't short each other out or connect. So I'm somewhat confident, I'm not completely confident, and I hope I didn't burn or ruin anything, but we'll find out soon enough. So I got the laptop over here, Arduino IDE set up already. So I'm going to connect these wires now. No, that's the wrong way around. Black to ground, blue to data 4. And this one to the power. Alright, so everything looks to be not touching each other. It's the moment of truth. I can see that the LED is on. I don't know if this is visible on camera. I don't want to twist too much from the cables now. I can select my USB device. I got one temperature. 0, 1, 2. All 3 temperature sensors are working, for which I'm really happy. So this contraption seems to be working fine. That's amazing. Okay, let's see if they all heat up. I think this is number 1. No, this is number 2. Okay, this is number 1, and then this should be 0. degrees, 25 degrees. So all the sensors are working, everything's working. Okay. So I'm really happy and somewhat amazed that this is working now. I'm going to look for some electrical tape. I should have it somewhere in the house, I just don't know where now, to make sure that I don't get a short circuit. That's probably the safest option, to not fry anything. And then we'll continue with creating and designing a 3D printed case in Blender. I found some old electrical tape and heat shrink tubing. That's, I think, from when I was 14 and still had my boat. I'm a bit limited in available sizes, but it should still do the trick. Preferably you also add this before soldering the wires together, as I now have to struggle to get it over the DuPont connectors. And after quite a bit of struggle and a few words of choice directed at one connector in particular, it took over 10 minutes just to get tube past it. I got this fairly nice and clean looking wire thing, which even surprised me. As a final step, I took all the measurements of the ESP32 board, the cable thickness from the sensors, and the amount of cable that I have to hide in the casing. And with that, it's time to check soldering off the list and move on to 3D design. For the 3D design I used Blender. I started off creating a mock-up of the ESP32 board and modeled the case around it. I find it easy to work from the bottom up, as that's how it's printed as well. You can then keep this into consideration by beveling or sloping edges, often resulting in no or very minimal supports for 3D printing. In the end, I pushed all the complexity towards the top, right under the lid. There's a platform for the ESP32 controller to sit on with an opening for the USB-C port, a cavity in the bottom to hide all the cables and the connectors, and I went for a tight zigzag pattern that holds the cable from the sensors in place. So even when you might tug on them a little bit, the force is transferred to the case and not the internal electronics. And I used the part in the center behind the ESP32 controller as a sort of a notch to catch the lid and keep it into place as well. And that's it. The 3D printing setup is pretty straightforward for this one. I created a new project in Bamboo Studio with 2 print beds and imported my parts. One print bed is for the case and one is for the sliding lid. I check all the edges and hanging surfaces and make sure that everything's fine. I set it to 5% gyroid infill, no spots, and send it to the printer.
The clock doesn't tick here. Without a sound, like the edges turned around. Every light begins to bend at the edge of where you stand. I was living half awake, now I'm not sure what's at stake. 'Cause your presence doesn't burn, it just makes the world unlearn.
I am super happy with how this first print came out. Designing something once and having everything work or fit on the first try is just the best feeling. Unfortunately, that wasn't really the case for this one. Everything looks good, but there was one major oversight. And the ESP32 board cannot enter the case. This was a major design oversight from my end, so I tweaked the design a little bit and printed it again. Here's version 2, and the ESP32 controller now fits nicely into the case. But I wasn't really happy with how it's set in the case. The USB port doesn't really line up nicely and the cables which I probably should have tested on the first case. They are really hard to push in. They were too hard to push in for my liking. So for the third and final version, I added a tiny bevel on the outside edges to make it feel a lot nicer to hold in your hands as well. I changed the interior base, I lifted it a little bit on which the ESP32 board sits, and I adjusted the cable tracks. So this is the final version, and no, the gray wasn't intentional. I forgot to update the loaded filament after a different print, but functionality wise everything should be good now, and let's see if everything fits into the case and works as intended. Putting everything together was very easy. Connect the 3 cables, seat the ESP32 board and push the 3 cables from the sensor into their slots. The lid fits perfectly and the USB port lines up nicely now as well. I'm really happy with how clean this case looks. Let's hook it up to the computer to see if everything is still working. I was very happy when I saw all 3 sensors reporting data in the serial monitor. I now have built my own working 3 sensor ESP32 thermometer. And although it's a bit hard to see with the studio lights, the LEDs from the ESP32 board are also visible through the lid as well. I did the whole check again, holding the cables while watching the serial monitor and looking for the temperature that rises. I switched the cables in the case so they follow the correct order now, going from left to right, sensor 0, sensor 1 and sensor 2, with the USB port from the ESP32 board pointing downwards. I'm going to label the cables afterwards with the sensor numbers as well, so I know which sensor is which and measures what. So I know which sensor is which sensor. You know what I mean. And with that, after placing the lid back, my very first Multi Sensor ESP32 Thermometer project is done. So, let's see if my DIY project was cheaper than the 40 or 60 euro product that I found in the beginning of this video. So here's a final breakdown of the material costs for this project. I paid 16 euros and 13 cents for 3 ESP32 controllers. So let's just say 5.5 euros for one. I paid 3 euros 87 cents for the breadboard, so let's make that 4 euros. 5.94 for the Elegoo wires, so make that 6 euros. I paid 9.72 for 5 temperature sensors, so about 2 euros for one sensor, and I used 3, so 6 euros. And 13.58 for the overkill 1250 piece resistor kit, where I only needed one, so let's say 2 cents for one resistor. Print in the case 3 times was 120 grams of filament and the lid was 8 grams. So 128 grams of basic PLA, taking 15 euros per kilo or per roll, is about €1.92. With some printer maintenance and power, I'll just put it at €2.50. Using flux, solder wire, heat shrink tubing, all that I had, but let's put that at 50 cents material cost. Everything around it is upwards, and this is also R&D, 3 parts that were printed, so it will be cheaper if you redo this, of course. Shipping is not included and not taking into consideration any hourly wages for the time spent. Learning new things, gaining skills, building experience and knowledge is far more valuable than a basic hourly rate, I think. And I also spent a lot of time recording videos while building this, so it wouldn't be accurate at all. And the final number for the 3 sensor ESP32 thermometer is €24.52. which I'm really happy with. So for about half the price of existing products and investing a few hours of my own time, I now learned some cool new techniques and I have a custom solution that fits my needs exactly. And I don't need any other third-party apps or whatever, it does what it has to do. And I also have a 3D printed case that makes for easy maintenance, troubleshooting or upgrades, and I have way more options for tweaks, upgrades later on. And what I currently do with this 3 sensors in the terminal monitor or in the serial monitor is very basic. The ESP32 development board is capable of way more, and I haven't even scratched the surface yet with this project. But yeah, I know this wasn't the most flashy or difficult project, but I had a lot of fun experimenting and learning new things. And I can't wait to learn more about the ESP32 boards and what they are capable of. I hope you'll join me on this journey and might even get interested into building or trying something new yourself. That would be amazing. The 3D printed case will be available on MakerWorld and probably printables as well. If you want to try this project yourself, you can download and print it from there. Let me know if you also made any ESP32 projects already or what might be cool for me to try next. I love sharing my experiences and I'm always learning new things. And yeah, I want to show that if you have an idea or you just want to make something, you can just do it. In my next video, I want to step it up a bit and create a desk lamp, combining 3D printing, ESP32 and WLED. So make sure you're subscribed to get notified when that project video goes live as well. New videos on the 3D printed smart LED wall panel project are being made as well, where this temperature sensor of course will be featured again. That's what it was for. And that was it for this video. Like the video if you liked it. Definitely let me know what you think in the comments down below. Thank you very much for watching and I hope to see you in the next one. Goodbye.